So I showed you before that you can standardize variables within the linear model command with a scale function, and you get, if you standardize the dependent and independent variables, you get betas for the regression, and that's good. An alternative possibility is that if you have loaded the package lm.beta, you have this convenient function lm.beta that essentially transforms the fitted object such that the summary gets you also the standardized coefficients. So if you take any of the regression that we ran before, here, let's do a simple multiple regression without the scale around here. We do this. Okay, if we just do that and ask for a summary, we get only the unstandardized coefficients. If we do this, the easiest way, I think, is to pipe the output of LM into lm.beta, and we ask for the output for the summary of the object. We see that we have both the non-standardized and the standardized coefficients, the standard errors and the t and the p-values. And then we have, of course, the r squared. Sometimes it can happen that you see this. That's not a problem. It's just because it says that it's too small here to draw the plot. So when it gets too small, it complains. If you want to shut down the plotting device, you just either click this symbol, clear all plots, and it will stop complaining, or use dev off here. It will stop complaining as well. Now it says you have nothing to shut down because I shut it down here. Okay, so the lm.beta, it's convenient because it gets you beta coefficients without having to manually standardize all the variables. Okay, now I will have, well, this will be an exercise on the linear regression. I think we may skip this, but I left all these exercises such that if you want to try something at home, you have something. And the multiple regression, of course, is just separating predictor with a plus symbol. And we saw that as well. And one last thing, Florin before the break asked me, what if I want to get simple plot, simple effect, or simple slope analysis? Well, that's not, I mean, it's harder than you could think, because there is nothing that from LM, like a function that takes fitted object from LM and gets you the simple plot. But in Psych, you have this function, it's mediate. It's called mediate, but does both mediation and moderation analysis. So you can specify mediate, the moderator or mediators, I think at some point. Let me see, maybe, yes, also moderation. So if you check this function, mediate in Psych, you will get some option to get simple effect and simple slope analysis for interaction. You also get mediation analysis and with the diagram and everything you want in mediation and moderation. It's somehow like our version of Precher and Hayes's process. So should also do bootstrapping, I think, for mediation. Let me see. No, maybe not. I'm not sure. But then to start about that, just look up this function. Now let's switch to ANOVA. Who of you is familiar already with ANOVA in R? No one? You are? No, but You should raise your hand like proudly if you have done ANOVA in R. Okay. Don't be shy, because I cannot. If you raise it like this, I cannot see them. You ANOVA? No. No. Okay. Then I will show you ANOVA using a package that is called Easy. So the name says it all. The point of this package is making ANOVA in R extremely easy. Why? Because otherwise ANOVA in R is not easy. That's one of the features of R. If you again, if you want to run complex models, they are not necessarily difficult, but simple things sometimes are difficult. And ANOVA is one of those, because if you want to specify within subject ANOVA, then you manually have to specify the error structure. It's not very convenient. But if you do that in vanilla R, and also having plots is not necessarily easy. And whereas package Easy has been programmed to make everything very straightforward. So between subject, within subject ANOVA, and the plots, and everything is very immediate. And well, also in R, the default will be using type 1 sum of squares. Type 1 sum of squares in ANOVA are, well, a bit problematic. Can be a bit problematic, because we are not used to that kind of thinking. So type 1 sum of squares means that the first factor that you specify in the model tries to explain as much as variance of the independent variable as possible. The second factor tries to explain what's left from the first factor, and the third factor what's left from the first two factors, etc. And that's not very good, because then which factor is significantly associated to dependent variable depends on the order in which you specify the factors. In some contexts that can be desirable, but I've never seen that used in psychology, honestly. And Easy uses by default type 2 sum squares, so that's a more principal option because they are not sequential. If you want, you can specify type 3 sum of squares, which is the default in SPSS, but that only affects the interaction, the NHT-test of the interaction effects. We stick with the default type 2, but if you want type 3, you just type equal to 3 as an option in the function that we will see. Another thing that you may or may not like in Easy ANOVA is the treatment of covariates. So when you do ANCOVA, because the typical approach in SPSS, for example, to covariates is to treat covariates as if they were as predictors, as just continuous predictors in a regression. Whereas Easy ANOVA treats covariates literally as variables that you want to control for. So it takes the dependent variable, it partial out the covariate, and then it runs the analysis. So you won't see the result for the covariate in the output. Well, that's the way Easy ANOVA does it. So there are other ways to do ANOVA, but we will stick to this because it's has well many positive features, and you will see those. The syntax, which is too small here, I will try to make it bigger. Okay. To run the ANOVA, the command is Easy ANOVA. How do I do this? Okay. The command is Easy ANOVA with a capital ANOVA. You have to specify some. Yes?
Johnny, just one comment on type 2 sum of square.
Yes.
Unless you think there is no interaction, you shouldn't use type 2.
Okay.
So you are sure that there is no interaction, then you use type 2. If you think there might be an interaction, then you use type 3. That's why SPSS and Genomic use type 3 as a default, because assumes the possibility of interaction. Bottom line is, I understand that that's the default. I don't think it's a good default. That's just simply a minor thing.
So I don't remember. Is that I think that type 2?
Type 2 assumes that there is no interaction. So type 1 is sequential. Type 2 is not sequential, simultaneous, but says all is explained by first, they depend by the independent variable, and there is no interaction effect. Type 3 says there is also an interaction effect. That's why.
I saw that, but then I think that type 2 essentially fits the interaction on what's left by the independent.
Yeah, but yes, but it assumes in the division of the sum of squares, it assumes that there is no interaction.
Okay.
So it's a residual.
Yes, exactly.
Yeah.
Yes.
Type 3 is part of the calculation.
Exactly. Yes.
So bottom line is, if you think there is an interaction effect, type 3. If you are unsure, type 3. So don't use step 1, don't use step 2. Unless you have strong reasons.
Okay.
You can basically specify type 3.
Yeah, well, let's specify
Sometimes the
that.
four are useful, sometimes the four are not useful.
Yes, I don't know why they specify type 2, but I think that there is an ongoing discussion, like one of those discussions that goes on forever about which one is better. And I never got deeply into that discussion. I just, type 3 is okay. So the function is ANOVA, and the first argument you want to specify is the data set, just data. The second argument is dependent variable, and the third argument is WID, so the identifier of the subject. Now, these three arguments are mandatory, no matter what. What I find that it annoying sometimes is that the subject identifier is needed even though you do between subject and ANOVA. So it wouldn't matter because in between subject and ANOVA, each line is a new subject. But still, ANOVA doesn't work if you don't have a variable specifying the subject identifier. So, now, the good part of this function is, okay, let's start from this in bold. Between is the between subject predictors, and you just need to specify C list, so C, open parentheses, and all the names of the predictors. They don't need to be as text, so in inverted commas. You can just specify them with the names without inverted commas. Between covariates are the between subject covariates. Okay, type of some squares, okay, is you can choose type 3. Now, if you have a within subject ANOVA, you just specify within as predictors, within subject predictors. Now, this one is tricky. So, easy ANOVA, if you have within subject ANOVA, expects data in long formats. That's good because I mean, in R in general and in ANOVA in particular, they prefer using long format because it's more general. Also, if you have, for example, very unbalanced data in terms of number of trials, instead of having many empty columns at the end of the file or something like that, it's easier to get data in long format. It's more general, and if you have, in some cases, it's also more compact. But sometimes you have many variables within subject variables, but only some of them are of interest for your specific analysis. For example, in the ANT data, you have the flanker and the queue, and I don't know, the trial and the block, stuff like that. And it can happen, not in the ANT data, but it can happen that your data is unbalanced. So, for example, I don't know, you remove trials, you remove some outliers for reaction time. So you don't have the same amount of trials within each queue condition, but you are only interested in the flanker condition. Imagine that. So you have 10 trials in the queue, I don't know, in the queue present condition, 100 in the queue absent condition. And both of them are in the same flanker condition. If you don't specify anything in within full, you will take the average of 110 trials. So one of the queue condition will be weighted much more than the other. If you specify Q as a within full means tell me all the manipulated within subject variables, even those that you don't want to use in your analysis. Then what R will do is take the average of the first 10 trials in the Q absent condition, the average of the remaining 100, and do the average of those instead, so that the Q condition will weigh the same. This is only important if you have unbalanced data. But then it's safer to specify. If you're not sure, it's safer to specify all of your within subject manipulated condition as a within full, even though you don't want to analyze them all. Within covariates are within subject covariates, so variables within subject that you want to partial out before running the analysis. And that's mostly, a couple of additional arguments are detailed. So if you put it through, it gives you some more information, like assumption test or something like this. And return AOV. So return AOV needs a little bit of discussion because easy is a non-standard way to do the ANOVA in R. The standard way, I mean, the way that it is built in R without calling any further package is the AOV function. If you ask for return AOV, easy will give you not only its output, the easy output, but also the classic R output. Because some functions, for example, to compute f exercises or additional f exercises or to do post hoc analysis, they will rely on the AOV output. So easy can give you that, but you need to ask. Return AOV, put it to true. Now, it is impossible to remember all the arguments of all the functions. So your task is, of course, not to memorize everything. You just go to the help file, and then what I do when I use Easy ANOVA is I have the help file on the right, my script on the left, and I check, do I need this? Yes. Do I need this? No. And check all the arguments and try to fill them in. And the good part also of Easy ANOVA is the function EasyPlot, because essentially all these arguments are the same. Are the same as those that you get in Easy ANOVA. This function, of course, gives you a plot of the results. So all these arguments are the same as Easy ANOVA. So you can just copy paste the Easy ANOVA code and then specify how you want to visualize the variables, like the independent variables. On the x, which one on the x-axis, which one defines separate lines, which one defines separate plots by row and by columns. We will see that in a moment.
It's a stupid question, but Easy ANOVA is a function or is a package?
Easy ANOVA is a function. Easy is the package.
Okay.
And Easy ANOVA and EasyPlot are two functions within Easy.
Okay. So I don't have to install it because...
Yeah, you just made you load it before. The trick is I ask you to load everything at the beginning of the lesson. Any questions so far? Okay. Let's try. Let's see what's there. Okay, so we can use this file canova.sav. Is an SPSS file. Now we will use. So I use this file also because you will see one of the. Is it not there? Maybe you need to download again the. I updated the data set to this morning in the. I mean, before the starting the lecture, I updated the data sets in the slides. So you can, don't you? In the link, this link. Where is it? Here. So if you don't have it, just go here and you will find it. No. Okay. Awesome. Did you manage to download the data? No. Let me check if it works, just to be sure.
It works.
It works? Okay, awesome. I'll give you a moment to. And remember, if you have any question or if you get stuck at some point, just call me or Stefan, and we will help. Did you copy this? Awesome. So, let's try to open this. Okay. If I open this file, the ANOVA data, again, remember to put haven in the set of the packages that you load. We will see another annoying feature of R. So the feature is this one, that let's do this, Lapli ANOVA class here, that variables such as gender, nominal variables, in R are typically factors. And factors is the way of R to define nominal variables. So that's just numeric variables with attached labels. However, the package haven that we use to read SPSS files has decided that it will be better to represent factors as haven labeled, a format that not many other packages want to use. And that can be a source of errors, because haven labeled, well, easy doesn't like haven labeled. So what you can do is this as factor. If you do this, then the nominal variable are now factors. This is as underscore factor, is a function in haven labeled that essentially says convert all this haven labeled gibberish stuff to factors that are more generic format.
You can also open with foreign, another library for.
I know, but the foreign hasn't been. I think it's at some point it was discontinued. I don't know if it's back.
I just did it.
Oh, okay, awesome. So then it was updated eventually. And the other reason is that this one is here, and people then struggle with programming for opening data. So if I give them foreign, then you have to specify some option, and I mean, my students typically,
Get confused.
Get confused. Yeah. Okay. Did you manage to import the data? Okay, awesome. So you can specify it with the pipe, the asFactor command, with the pipe symbol, or you can save the results of read stuff to an object and then use asFactor on that object, which is the same of using the pipe symbol as we did in the code. Okay, let's try to examine whether the verbal argumentation score, argum, is affected by education. Yes, or if education affects the verbal argumentation score. And generate a plot with the function EasyPlot. Essentially, for generating the plot, you just need to copy-paste the ANOVA code and decide that education goes on the x-axis. So, easy ANOVA, open parenthesis. Now, the data, C ANOVA. The dependent variable, we said, well, I absolutely don't remember the name of the variables here. So I do names, C ANOVA, and the dependent variable is argum. Then the within subject identifier is ID. Then we want to specify, independent variables, which is between subject, is education. Anything else? Let's go to question mark easy ANOVA. We do a double check. Dependent variable within identifier within variables predictors are not important. Within subject, we have between subject predictors, we specified it. Covariates, we don't have them. Observed. Observed is another argument I didn't tell you about. If you specify here a list of which variables are observed, then the easy ANOVA package will compute the generalized eta squared instead of the partial eta squared, where the generalized eta squared, there is a reference below here, is just a measure of effect size that tries to compare the effect size for observed predictors with that of manipulated predictors. I'm not sure that this is a good idea, so I typically don't specify that. You get essentially a partial eta squared as effect size. Diff, and this thing I didn't show you, is just if you want to collapse dichotomous variables as difference, take the difference of them. And type, we want to specify type 3 sum squares, so you just type, what is it? Here, type equal to 3. These things, we just skip them for the moment. Okay, so we can then run it, and we get the output. So it often happens in order to get something red that may make you feel threatened, like, oh no, it didn't work, but sometimes it's just peaceful warnings. Like it says, I converted the ID to factor for ANOVA, that's reasonable. The data is unbalanced. Make sure that you specified a well-consistent value for the type argument with it. And, well, it says that coefficient covariance were computed with this function. That's not relevant for us. And we have the ANOVA. The f-test with 96 degrees of freedom is this one. The p-value, and this is the effect size. Essentially, is the partial eta squared. In this case, it's just the eta squared because we have one predictor. We also have the Levin's test for homogeneity of variance. And what if we want to get a plot? We just copy paste all of this, and we ask for easy plot. The only thing that we want to specify is that education defines the x-axis of our plot. I mean, that's obvious, but if you have more than one predictor, then you need to specify which one is on the x-axis and which one goes on different lines. And here is our plot. This, I mean, essentially this is a ggplot visualization. We will see more of this type of plots the last, I think, on Wednesday. Yes, Wednesday morning.
And there is a lot of friendly warning, or?
Yes, lots.
Okay.
You will know when they are unfriendly because the things won't work.
But I would suggest maybe another color.
Yeah, they really like red. That's you know, there are packages. In some of the, for example, in some of the packages, for example, we will see that when we will do power analysis, when we'll see SIM-R, you know that sometimes when you get mixed models, you can have a singular fit. And it gives you an, well, not very friendly warning that the fit is singular. When you do a simulation around that for power analysis, you get a warning every single time, like is singular, is singular, is singular, is singular, is singular. If you do 10,000 of that, you will get 10,000 red lines. That's quite scary sometimes. But then you, yeah, don't panic and read the warnings, and everything will be fine, hopefully. Did you manage to get the plot and the ANOVA? Awesome. Each one of you? Okay. Now, maybe you want to get estimated marginal means, because you don't get that by default in Easy ANOVA. So one trick to know the values represented in this plot is to save the output of the plot to an object. I typically call that MNS for means. You run that again, and if you just print what's in MNS, oh, come on. Print. Oh, I'm sorry. If you take MNS $data, you get the data that Easy ANOVA used for this plot, which are just the estimated marginal means. This, and this.
Show a bit higher, upper.
Oh, yes. Yes.
What do you have changed?
I just, okay.
MNS object.
Yes, exactly. I just took the easy plot and I created, I assigned it to an object. And then I take the data element within the MNS object. That's just it. And I see the estimated marginal means.
Low and high are the confidence intervals?
Yes. No, actually, yes. And it uses, yeah, low and high are the extremes of the, yes, this should be the confidence intervals. So, but we need to check the details here. La, 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 la. Yes. So it uses this method for computing the confidence interval. Yes. Okay. Okay. And this is, well, it's just a description of what I told you before about the generalized eta squared. So if you want to really use this suggestion to use generalized eta squared, then you read this paper, you specify that the education is on observed variables, and you will get slightly lower eta squared, generalized eta squared, essentially. Smaller effect sizes. Whereas if the variable is manipulated, you will get the same values as eta squared. Now, how would you get post-hoc tests? Well, you first thing, you need to specify in this ANOVA return A of B equal to true, and then you get also the and you say, I'm sorry, you specify return A of B equal to true in your code, in Easy ANOVA code, and you save it to an object. And then we'll see how to get the post-hoc. So you do this, return A of B. It's raining a lot. True. You get the usual warnings. But then if you check your, okay, let's do this. Maybe I close the door here. Okay. If you look at the fitted object, you now have three outputs: the ANOVA table, the Levin test for homogeneity of variance, and the AUV object. This one is the one that you need for having postdoc, and you can use the TACI HSD function to get TACI postdoc here. You get by default postdoc for all possible combination of all factors. You can, in this case, we only have one factor, which is education, so you get postdoc only for education. But you can ask, if you have more than one predictor, you can ask postdoc for which specific predictors you want. So, for example, in this case, we see that this is the only significant difference between the two. There are many other options for postdoc in R, but they are more complex to get, actually. So I will stick for the moment to just TACI. You have packages that give you more control over postdoc tests. What happened? This is not a double single. This is a weird circuit. Just a dot. Okay? Everyone okay? So, and that's it. I mean, the good part of this package is essentially that with a small variation on this theme, you can run also within Subject ANOVA, Mixed ANOVA. They are essentially easy extension of this. Let's start with Factorial ANOVA. So maybe you can do this in autonomy. So you need just to add another argument to the between option. For example, let's also include gender as a predictor in the previous analysis. And when you add it in the between, remember to put it in a list, like C, open parentheses, education, comma, gender. And the other thing is, you want, in the easy plot call, you want to specify, now that you have gender and education, how gender is represented. For example, you can split the plot in two lines according to gender. Try that, and I'll give you assistance if needed.
Una qualunque dice genere.
I know. Maybe not. Something
Non è sufficiente fare così.
It's harder. Okay.
Split row.
The setup with me, we don't pipe it into the, what is the pipe? Setup with me, if you want to use it, use it. It's not an arbitrary. That was a good time. I think it's just a factor around the whole thing.
A different solution than what?
Regression plus.
I'm not sure, maybe
And
you
it
converted
gives you also
some variable for
interaction.
different content in the process.
Synthesis of
And one of the reasons it's good to use, so to call the data in the code, that the code flows, it's a predictable. So you can check whether you made a mistake and code to correct it. Whereas if you import the data, you don't know which point the data were loaded, and so you cannot re-execute the code exactly like the code for it not was correct. It was a problem in the data.
The same for easy process.
Oh, something weird. Everyone got this. Awesome. No, I think I know why. You cannot put them both in the x-axis. You can put one in the x-axis and one under the split angle. So,
How is the split angle?
okay, comma, new line, education, and then do split equal to general. Funziona. È un altro modo, ci sono tanti modi per specificare. Funziona. Anche con non so come.
L'altro
Simple, you have to split.
Mancava solo il piccolo doppio di
No, standard deviation sono
Sì,
diversi.
no, sicuramente questo, sì. Sono interventi di confidenza, sono tutti uguali, perché usa questo Fisher List Significant Difference che di fatto li piazza tutti uguali.
Scusami, come
Assume che non mi ricordo, però c'è tutta una spiegazione dentro l'altro di EasyPlot su come fa a definirli.
calcolo comunque la stima di variabilità.
Sì, fa una cosa di questo tipo. infatti è molto
Ma diciamo che vedete come va,
cioè puoi, ma devi fare una heavy manipulation del blocco ggplot.
Cioè, conviene farlo da zero, devi farlo vedere.
Conviene farlo, no,
Cioè, nel senso di andare
cioè,
bella
tipo,
dinamica,
sì.
vai che stanno a 10,
sì, esatto.
I have one question.
Sure.
For instance,
Yeah.
if you name an object like MNS, but you also have before,
That's very easy.
so right. So you have to name it differently if you want to.
If you want to keep that.
Sì, no, ma tu devi cercare di
You just let's just because you see there. So if you just want this,
sì, è sempre identico.
Everybody fine here? The last row. Okay, so you want some help? Let's see if you are already at the post-op tests. So that was it. So you needed just to copy paste the previous code, add also gender to a list with education in both is ANOVA and plot, and then, for example, split by gender. You could Marco Perugini also discovered that everything works if you want, even if you separate predictor with a plus symbol. So like between education plus gender. If you do that, everything stays the same, so it works. Also, if you save the output of fitted object, that holds for also, let's do this, split gender. If you save the output of MNS to EasyPlot to an object, MNS or something, it doesn't give you any plot. You have to print MNS in the console, and then you will get the new plot. And what else? Now that you have two predictors, when you run the TAC-HSD function, you will get, let's do this. You will get post-hoc comparison for each of the factors. Education, gender, even though not particularly relevant, and also the interaction effect. If you want post-hoc only for one of the factors, you can specify the which argument, for example, education, and you get the post-hoc only for the education factor. I mean, it's not very relevant. You can just get them all. Here. You can just get them all and then take a look of the factors of interest. Any questions about between subject ANOVA? Now, let me see.
How can you get the TAC for all of them? Because
Just
something split also, like in.
No, just you just specify TAC of the fitted object $AUV.
Yeah, I do that.
You don't get the postdocs?
Only for education.
Because you don't have a comma here, so it didn't work. Yes. Yeah, that's the 99.9% of errors in R is that you don't get a comma somewhere, or an extra parenthesis or a missing parenthesis. as all programming. Other questions? So ANCOVA, just a simple extension of this, because you include something in between covariates. So, for example, let's control for the age of the participants the variable birth year. If you in between covariates you put birth year, then it will first partial it out from the dependent variable and then do the model. So you can try to add birth year in between covariates, and then you will get the results.
It's the one that includes gender or without? It's the same. Factorial?
Yeah, with the gender. Just yes. So you just need to copy paste the code that you just read, and then include between covariates equal to birth year, both in easy plot and easy ANOVA. And of course, you don't need any further specification in easy plot, because yeah, it's just parcel out.
But I missed what is the covariate?
In easy ANOVA, the covariate.
No, what is the variable that we should use?
Birth year.
Ah, okay.
And it's birth.
Yeah.
But
It's just birth.
I guess so.
Yeah. Then.
Just have a check here too, but
Yes, it's probably birth. Okay. Yes. So sorry guys, it's birth.
is there any place in the summary function that tells me that I'm partialing out something?
Don't think so. I don't think so. Also, it tells you that when you do this, it tells you that all of this is experimental, and yeah, you should let's do this. Like between covariates, birth.
Because you don't have the coverate. If you you said that easy ANOVA doesn't give the coverate the F value, so
Exactly.
you don't know if it's a legitimate coverate or not. If it's
Yes, you don't know.
So is there a way to have this information?
yeah, you can do a correlation between the two.
I mean, the point is
Very dependent variable.
if you want to include it as a predictor, let me check. Maybe let me see if this works. I'm not sure, but maybe. Oh shoot.
But then it computes also the interactions.
We compute also the interactions. Yes. Let me see. So
So from the output you
no, it doesn't. It doesn't do anything. So if you really want to have birth, like a covariate treated as a predictor, there are essentially you want to do it with the function A of E. So you need to step out from easy and specify an A of E model in which you have a formula syntax like a regression. So you will have so which was the dependent variable here? The argum tilde education plus gender plus birth data equal to ANOVA, you save it to fit, then you can have ANOVA of this, and also you specify that you want the interaction effect here. So you have the education, gender, birth, education, gender. Problem is, these are type 1 sum of squares. So what you also want to do is add another package. So that's why I told you ANOVA in R is not simple.
That's why you teach easy.
You have a function in package car that is called capital ANOVA, and that gives you type 2 or type 3 sum of squares. Again, you can specify type equal to 3, and then you have your type 3 sum of squares, and then you have the test. So, and then you have, yes, birth as a continuous predictor. But that's a little bit more complicated, but not that much complicated. When you switch to within subject ANOVA, it gets complicated. So that's why I stick to easy. Also, you don't get any plots, etc. But then you can absolutely do that in R.
But maybe it's easier to just do the regression to see whether the covariate has an impact, and then.
Or yes, the other possibility is that you do the regression. So you do all of this as a regression model.
No, what I meant is you do the regression just to see whether the covariate has an impact on the dependent variable. Because the point of this variable is that you just take away the variance due to the covariate, right? And then
to see the syntax, you just wrote it.
Okay. Yes. Sorry, that was screen small. So yeah, but that's a theoretical question. So if you want to partial it out, for example, because you suspect that could have some confounding role, it doesn't matter whether it is statistically significant result. I think you just partial it out. It should not be guided on the.
Yeah, but your reader may want to have this information then.
Yeah, of course. Yes, you just do a correlation, as I said. And yeah. Other thing, of course, you can do this with a car package, and then it works. And within subject ANOVA gets complicated, but a more principal thing is don't do within subject ANOVA and go to mixed models instead. And then you are, and that's, it's easier to handle mixed models in R than within subject ANOVA. And you can do anything that you do within subject ANOVA within the mixed model framework. So, yeah. So this will be the way to do ANOVA between subject ANOVA in R without easy package. Any questions? Still, if you, if this is, if you have any curiosity, anything that you want me to explain in addition to what I put in the short program here, just ask and I will be happy to give you further information, like Christina just did, or if you have any question, and ask at any moment.
I never quite understood how do you interpret interaction effect? Like, what does it mean that education interacts with gender?
Okay. So how do you interpret interaction effects in between subject ANOVA? It's just that means that the effect of education is different for males and females, and that I think it's easier if you consider it in the regression framework, but maybe with continuous variables, because otherwise it's a mess. The fact that you have an interaction coefficient in the regression, is it clear, or is it? Okay, so in a regression, if you have an interaction, a coefficient for an interaction effect, this is the change in the effect of one of the predictors when the other predictor increases of 1 unity.
Okay.
So, for example, if you have, imagine two continuous variables could be, let's do this on the Boston data. medv predicted by oops. Yeah, the tilde symbol. Medv crime rate and indus. That's those before. Data equal to Boston, and then summary. Of course, it's better to center those, but we ignore the problem for the moment, and we see that you have an interaction effect here. Means that the main effect of the crime rate on the dependent variable, the value of the houses, for each unit increase in the industrialization increases of 0.29. In this case means that the effect is attenuated. In the ANOVA framework, that's essentially the same, because if you check the summary here, here, of this, which is just the regression behind the ANOVA that we did before, you see all the individual coefficients. So the factors under the hood are treated as sequences of binary variables. So you have, I think, less than high school will be the baseline value. Then you have a binary predictor, which is just whether the person has the high school, a degree, or a master or PhD, and one unbinary predictor for gender. And these are interaction effects. The meaning is the same as in the regression framework. So essentially it's saying that the compared to not having the high school, if you have the high school, the expected value of your argumentation score increases of 0.4. But then if your gender is female, this increase is slightly but not significantly reduced. So that's the meaning of interaction effect. And this is essentially the difference between males and female in the effect of high school on argumentation score. So that's, yes. Did I answer your question?
Yes. Thank you.
Other questions? Awesome. So let's, well, ANCOVA, we've seen it. And then what if we want to have within subject a mixed ANOVA? Essentially we just want to specify within subject variable and within full argument. Let's see how long time we have. 15 minutes, that's enough. So let's try, maybe let's do that together. We go to the ANT data and we predict the reaction times from the flank and Q variables and get the corresponding plot. So the data ANT, we already should have them loaded. So within subject ANOVA, we just have easy ANOVA. Data are ANT. WID should probably be ID, but I don't remember. So names ANT. Let's check it out. Now it's subnum, the identifier. Then we want to specify dependent variable is reaction times, lowercase. Then we have within is, we can probably this and this Q flank. We can also specify within full. It's in this case is completely irrelevant because we are using both manipulated predictors, Q flank, and also data are balanced, so that's not relevant. But. And that should be it, I think. Yeah. Also, if we do that, we get this. Collapsing cell means first using variable supplies to within full, then collapsing the resulting means to means for the cell supplies to within. So of course these are identical, so within full doesn't change a thing. But still. Then we have a main effect of Q, a main effect of flanker, and an interaction. The interaction effect has a smaller effect size, but still not that small. we also have the Moschly test for sphericity, and also the output with the sphericity corrections. So Junfeld and Greenhouse-Geiser. And we can get a plot as before. Maybe we just copy paste what's in Easy ANOVA. We change the function to EasyPlot, and maybe we want, I don't know, on the x-axis. Let's see what I put here, the Q, and we split by flanker, and we can see what's happening, and that's it. We see a huge main effect. These are simulated data, of course, so the ideal situation. We see a huge main effect in which the neutral and congruent flanker condition are the same, but the incongruent flanker condition result in much lower reaction times. And we also have a main effect of Q, because no Q makes you slower than having center and double Q, and spatial Q makes you really faster, the fastest in all conditions. And we have some interaction that may be visible in the difference between double and spatial Q may be more accentuated when you have incongruent flanker condition. And well, that's it. I mean, the easy part is that within Subject ANOVA is just an easy extension of between Subject ANOVA and easy. And what if you want mixed ANOVA? For example, we have a grouping condition in here in the ENT data. So if we check the ENT data, too fast.
Yeah.
Okay, sorry. Okay. Slowly.
You don't need to specify within full.
I mean, you do need to do it if you imagine that you have unbalanced data, and then you need it.
So you just put it in to be sure.
Yes, exactly. I just put it in for teaching purposes. The most principal thing is you put everything you manipulate, any grouping factor of interest in the within subject data, you put that in within full, and then you put in within the rest. To put the same variable in one and the other doesn't change a thing, so just put everything.
And you don't put type 3 here. So it's not
Oh, I didn't put type 3. Sure. No, of course. Thanks for looking. And now with the type 3 sum squares, we still get the effects. Also, the effects are, yes, the data are perfectly balanced, so I'm not sure that it makes a difference. Yeah. Probably doesn't make any difference between type 2 and type 3 because the data are perfectly balanced. So, yeah. Sì. Questi perché i dati sono assolutamente ideali. Poi 91 è facile. Perché è facile. So, yeah. You may have noticed that in the output, the f exercises, yeah, they don't add up. I mean, the sum is larger than 1 because they are essentially partial eta squared. So partial eta squared, are you familiar with that? Just the proportion of variance explained what that one variable explains after you remove the variable explained by the other variables. So the denominator is not the same for these three coefficients. So they can be their sum can be larger than 1. Also, they are, I mean, ridiculously large because these are simulated ideal data. So, like in a perfect situation in which everything works like it should.
P related to 42.
Yeah, exactly. The p-value for the Q condition is quite, I mean, you can see also from the f values are a little bit large. So everything is nicely working. So yes. Any questions about the...
And it's the same for post hoc. bonferroni.
That's so there are ways to get post hoc also for within subject ANOVA. I didn't put them here because yeah, I need to fit the lesson in 1.5 hours. But then one way I think is you can do it with the function called how is it called? No.
Doesn't matter.
But there are ways. Essentially, what you do, you do paired sample t-test and then correct. And that's, I think, the easiest way to get the post hoc for within subject ANOVA in R. Yeah. Essentially, I think that the whole R doesn't like within subject ANOVA that much. They prefer you to do mix because it's really, I think it's easier to get. I mean, because I think there is a function. It's called pair t-tests. I don't remember where.
Pairwise comparison.
Where is it? Pairwise t-test. That one with the underscore. In which package is it? Yeah, maybe. Pairwise t-test. Oh, also this one. Okay. Then the one that Marco saw is different though. Let's see. The one with that, was it pairwise t-test with underscores?
Yeah, pairwise t-test. Function.
I don't see. I see the.
In stats.
Is it? Maybe then it's this one. And this one works like. Like this. So x is the dependent variable, but then I suspect that he wants the data in wide format. So,
Yes.
I think, so, let me see. No, grouping vector of, oh no, awesome. Huh, maybe not. Let's see. Maybe we take the response vector, so ANT reaction time is the x. The grouping vector or factor, maybe let's do it for flanker. The adjust method, the default is, what is it? Let's see. Oh, sorry. Typo here. G equal to flank, P adjust method. Bonferroni. and paired equal to true. Then I should tell it. I'm not sure. Huh. No. Yes, I want pair t-tests, so, but I didn't. No. Okay. It's probably not that easy for within subject because I didn't specify the grouping condition in terms of the subject, and then, yeah. Huh. No, I'm not sure that this will work. I think that we need to convert it to white format, and then we can have it. Like the cast int need reshape 2. The cast int, and then I have subnum tilde rare subnum tilde flank q plus q value var equal to reaction times and wide. Oh no, okay. Then I want to take the mean of those, so this I didn't show you actually. So and now I have this data set in which I have for each subject, for each condition, I have the mean reaction time. And then maybe I should do this. ANT columns -1, ANT column 1. Let's see if it works. It doesn't work. Why? Ah, ANT wide. Why don't you like it? Huh. I will look it up. I have somewhere in one of my courses, and but it is possible. It is possible. Okay.
Isn't that a big problem for us? Because most of the studies I've ever done were at within subjects variables.
I should.
Most of the studies I have ever done had within subjects variables. So why should I switch to R then? This is difficult.
Yeah, that's true. That's true. But if you do within fair point. But if you, my argument for that, if you do within subject variables, go for mixed modes. It's easier, and it's also easier to treat. There is this package that LM4, but then you over that you can use means, and that nicely does the post hoc and all the contrast for mixed modes. That will be easier if you want.
FIA. Post hoc interaction. FIA is another. Oh, FIA
is the one that does that. Yes. And then who is teaching mixed modes?
Yeah, we have.
We do have mixed.
Jamie and Marie.
You?
No.
No.
They're not here now.
Ah, okay. Okay. So I think yes, they will probably discuss it. The post-hoc test for mixed modes, and I think that's I will do that. Also, I mean, why should you switch to R? Because on the one hand, R is extremely annoying, as you have seen. It has and the reason it is so annoying is that people is writing packages, and they do that independently one from another, and well, it's often inconsistent the way you do things. So yes, for some things, like simple things like you want to do an ANOVA, Jamovi would be the better option. You get the ANOVA, you get the postdoc, you get everything. It's free. It's actually as are working under the hood. So yeah, but the data management in R is awesome. I think it's just awesome, especially for within subject data with complex condition, etc. You can do this whole transformation wide to long, long to wide, like with a few lines of code, and it's very clean. I love it for this reason. Also, the good part of R is that you can easily extend. I mean, you can write your own packages. So if you are dissatisfied with how things are done, it's not that difficult to write your own package and have it done your way.
Yes, and I can add one additional reason. See, anything is before in R and then it goes over it. It's the first line of programming these days in statistics. So which means any new development, any new package, any new test, any new things, usually you have a package in R, and perhaps you get it after some years in XSS, or perhaps not, or perhaps so on and so forth.
Yeah, that's true.
So, I mean, statisticians are writing in R. It's their language in R. Used to be S. Now it's R.
Nobody created an easy package for within.
That's a good question.
Yeah,
Why not?
essentially, yeah. Actually the way you will do this is with so no, it's not easy. I mean, you can do it in AUV, but then the postdoc are not that automatically done. I don't know why actually, because that's it seems that the whole R environment doesn't like within subject ANOVA. That's it. That it's unfriendly to within subject stuff. But still.
I'm sure there are.
Yeah, but maybe there are packages that, I mean, there are a lot of packages that we don't know.
Yeah, exactly. There are so many packages written every day. So if I have to confess, I typically don't work with so many within subject data, and so I'm not up to date. Maybe there is something new. When I created this course, I mean, my first courses in R, easy was the best way to do. Maybe that's improved, but not that I know of. I mean, there are other possibilities, but for example in car, but that's not easy. That doesn't improve in terms of easiness. Just that you have type 2 and type 3 sum of squares, and that's it. And well, the mixed ANOVA, it's of course, well, you just add between subject variable to the things, like in easy ANOVA you add group, which is some manipulation, imaginary manipulation, and you get the mixed ANOVA. So you get you get the main effects and the interaction at the within subject and between subject levels. And if you do that also for the plot, so between equal to group, you have to specify also where you want to represent the between subject variable. For example, row will get you different plot in different rows, so group, and you get not much space. So the control and the treatment condition, and you get different plots by row. Or by columns if you want them to be drawn by columns. That's it for within subject ANOVA. Maybe
You can leave.
oh yes, the code. Sure. Here. So essentially, yes, it's this one. So this and this and this. So, is this? Yes. It's lunchtime. Okay. But then, however, the general idea is probably, if you search very well, you will find a package that does it for you. I mean, it does things. So Marco has found a couple of them. One is Apex, that does come funziona.
And sì.
I remember that this FX package, when I tried it some times ago, it was more difficult than easy, so I picked easy. But then you do have packages that probably do things in a specific way, or
That's the other feature of art. Someone has done something that is working.
Yeah.
It's like Google, search and find.
yeah, exactly. So the thing is, I cannot teach you. I mean, all of them. Also, they keep changing, and they keep coming up. But I mean, once you know at least the idea of art programming, it's easier to extend. Also, I think there are not two persons in the world who program art in the same way. So each thing has plenty of possible solutions. It's like, yes, it's not a finite world. We did it. We have it. So I think this session is over. And I have this recap exercise if you want to try at home. It's little bit more complicated, has some things for edits, but that's more of the same. But any questions about ANOVA, regression? So I think now we have lunch, and in the afternoon, Daniele will tell you something about Bayesian statistics. So tomorrow that will be again me, and I have some about ANCOVA. That's actually not much. I mean, it's a very short part because a little bit of car package again, but it has also the ANOVA with type 2 and type 3 sum of squares. Maybe if yes, I can add something if there is something that you would like to know. For example, I can check more about post-hoc test for within subject ANOVA, for example. Is there any extension, anything that you would like me to cover tomorrow? But if that comes up, just ask me and I will try to figure something out.